Okay, I redrew the arc to correspond better with this initial vector. It didn't change any of the analysis, it's just I drew a pop fly arc, and this is more of a line drive coming out at 36 degrees. Anyway, the arc, it's going to rise to a level in my question of 9.5 meters on the way up and on the way down. And the question is what are the two times? Now, heights, how high a projectile rises is only a function of its vertical velocity. The horizontal velocity does nothing to lift the ball into the air. The vertical velocity's job is to carry it along to the outfield. The vertical velocity's job is to pop it up into the air to fight against gravity long enough for the baseball to get anywhere. So those two guys have different jobs, and as soon as you start talking about how high the ball is going, the focus is only on the velocity in the vertical direction and not the horizontal. So any velocity that is at an angle needs to be resolved into its components so you can appreciate what's going to happen horizontally and vertically. So get used to it. We're going to use vectors the whole semester, and everyone will need to be able to effectively take a vector v initial, and quickly and consistently identify its components and their directions, because that'll affect the sign of them. Positive up, positive to the right, negative the other directions. So let's start. The question is in the vertical direction, so I need to find Vy. Vy is on the side opposite of my angle, so I'm going to use sine. I'm going to say that this implies sine of 36 degrees is equal to the opposite, which is Vy over 30 meters a second. So if I multiply both sides by 30 meters, I'll be able to say Vy is equal to 30 meters a second times sine of 36 degrees. I'm not going to calculate that. Everyone will have different calculations anyway, but let's just say we now know our vertical velocity. So now the question is, if something is rising with a vertical velocity, how long does it take to reach this height? And perhaps how long does it take to come back down to the same height? Let's think about our kinematic equations. We have time, we have initial velocity. We want to find times. We have an initial velocity, and we have positions. This is this dreaded, complicated the most complicated kinematic equation. X final is equal to x initial plus velocity delta t plus 1/2 a delta t squared. In the vertical direction, our final location is h. Our initial location is 0. Our initial velocity, we just calculated it, it's Vy. Delta t, we don't know. A is the acceleration due to gravity, and gravity is going downward, so that's negative g, so that's negative 9.8. And delta t squared, I don't know. That's a quadratic formula. Let's see, we know, and just so we can, just to make that explicit, I'm going to bring this to the right because this is negative. I'm going to send it over. And just to be really explicit for people, I'm going to add 1/2 g delta t squared to both sides, and I'm going to minus Vy delta t both sides. 1/2 g delta t squared minus Vy delta t plus h is equal to 0. This matches the form of ax squared plus bx plus c is equal to 0. And that's a quadratic formula. That can be found somewhere in your notes. Be careful with it. Plug in these values that you have. You have all of these. So x is delta t, a is this coefficient, b is that coefficient. Notice that's negative, so careful of that. That's c. Plug it into the quadratic formula. You will get 2 answers for time. Both of them are valid. I think neither of them will be crazy, like a negative number or something like that. Both of them are valid, and those are the 2 times the ball reaches the level of 9.5 meters. This is an equation for a parabola. There's 2 solutions. Both are real. Next vid.